Hello, folks. Can I ask a couple of questions first? Who's actually programmed in Meteor here? Ooh, lots. Who's programmed Internet of Thingy things? Not quite so many. Sorry?
Does Alex.js count?
Yeah. Does what? Okay. So that's cool. It's roughly in line with what I expected, which is most of you are familiar with Meteor, not quite so familiar with physical computing. I don't really like the Internet of Things. I don't like cloud. I don't like big data. I don't like all these buzzwords. So, but that's what they wanted me to talk about, so that's fine. Another problem is that I actually, 15 years ago, was in a management consultancy, and we did a lot of PowerPoint, and it's absolutely mandatory in any deck that you have to have an exponential growth curve. So this is it. That's enough of that. Cool, that's fine. So we'll just get on to something more useful now. Because this is a bit dense, I'm going to tell you what I'm going to tell you. Then I'm going to tell you, and then I'll tell you what I told you. Right, so Internet of Things is moving pretty fast. As I say, I don't particularly much care for the name, but it is rapidly growing, and there's an awful lot of cool stuff coming out real quick. There aren't any real architectures that are fixed for actually hooking up all this cool stuff to the rest of the world, right? Especially things like UIs and controlling this stuff. I'll get to that in a moment. I can see some incredulous faces right now. There's also somewhat of an issue, which we just actually dealt with in the gaming side of things, which is that the fundamental paradigm of Meteor is running against the document base, right? And actually, it's events that happen in the outside world. Bing, bong, doorbell. It's not really cool to send that kind of stuff through the database in the gaming side of things. In real world, for example, you know, if I'm trying to fly my drone, I don't want to persist it to Mongo, right? But with a little bit of tweaking, you can do it, and I'm going to show you how. Let's quickly talk about some of the wonderful bits of hardware we got. It really started, I suppose, with the Arduino, which, how many people have heard of the Arduino? Yeah, lots. It's a fantastic bit of kit, very simple, incredibly robust. This is what they now look like, in fact. That's the sort of Mark I. Those are now about £2 each from China, if you wait for a couple of weeks. Wonderful. And there's lots and lots of different Duinos. DJ over there has got one with BLE right now, yes, thank you. And there's other ones with RF on them and so forth and so on. There's also a bunch of ARM-based stuff nowadays which run Linux of one kind or another, Raspberry Pi everybody knows about. This is a BeagleBone Black, which is absolutely a brilliant bit of kit. And it's, you know, that's a proper computer. And lots of other stuff. However, up until now, networking has kind of been expensive, or it doesn't adhere to standards, or both of the above, right? So Zigbee, which is XBee, which is a Zigbee-based stuff. Zigbee is a networking protocol which has never kind of taken off. It's been around for a while, and it's supposed to be a low-powered version of Wi-Fi, but it's still expensive and it's still a bit too juicy. And those are quite expensive. If you wanted to put a Wi-Fi shield on an Arduino, it's still about 30 quid. That's kind of expensive for a toaster, especially if you want it into production. And then there's things like the RFM stuff, which are fairly cheap, but some of them are limited. There's things like the NRF series, which is actually Wi-Fi based, or 2.4 gig based, but only will take like 80 byte packets. Right, which kind of limits your life a bit. However, as of about a few weeks ago, there is this thing called the ESP chip. And it's pretty astonishing. Here's one I blew up earlier. I'm not joking, I did blow it up when I was trying to get ready for this. I'm actually buying the posh ones now from China at about £2 a pop. They've got a full Wi-Fi implementation, WPA encryption, the whole bit. They've got a 32-bit processor, up to 4 meg flash. Sorry? Yeah. So this is pretty much a game changer. You know, I put a little blog entry on my thing. You know, this thing will change your life, and I really do believe that. This is just sort of slashed by a factor of 10 the cost of an Internet of Things thing. And although the stock version of these things comes looking like an old AT command-based modem to serial, some wonderful Korean gentleman has gone and ported this language called Lua to it. Any guys you heard of Lua? Yeah, right. So it's not the greatest language in the world, but it is pretty much a high-level language, and it's got a small enough footprint that I can actually fit it on here. And more to the point, he's also given us a node-like, not node, but node-like event-based programming paradigm on this, which is really cool because it means that folks who are used to the web, certainly used to Node, will feel relatively comfortable. In fact, it's quite funny reading the Internet of Things Arduino sorts of folks who are trying to program to this, okay? Because it's like this thing which is saying, well, I do a connection, and when I do a connection, I try and get an IP address, blah, 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 whatever. And they're saying, oh, how do you do it? You know, put a delay in, right? Rather than nested callbacks. So it's rather fun watching these guys, and I really need to write an article to try and explain to them what the way you work in a sort of Node kind of style. So that's great. You know, we've got Arduinos and lots of other stuff, nice things to play with. They're very cheap. And you know, these things actually will control real-world stuff fairly easily because there's an awful lot of other bits and pieces. You get accelerometers, you get pressure gauges, you get solid-state relays. I can turn the oven on and off with this thing, which is fantastic. But now how do we fit these into a real-world architecture and the rest of the ecosystem of the Internet? And that's the interesting problem. There are quite a lot of proprietary things. I'm sure that, you know, the other things. I left Pusher off there for a start, I think. But they are proprietary, and they kind of mean that you're going to kind of get shoehorned into their style of doing stuff, and they are out on the Internet. If you want stuff happening quickly, you've got whatever latencies are going back around like that. There is a place for these things, like Plotly is really nice for doing trend-based analysis. But as an example of what happened in terms of, you know, fairly big initiatives, Pachube, I think it was called Pachube. Was it the right pronunciation? Did anybody know? Yeah, it was Pachube. Ran for a long time. They've been running meetups in London, pushing the Internet of Things. Finally, they ran out of money. They got bought out by LogMeIn. You know, these guys don't actually have much of a business model at this point. They're just trying to get stuff. So I'm not that keen on actually tying my life into these rather proprietary systems and also having to work their way, right? I'm sure they've got a place, but I'm not quite convinced about it. Fortunately, there is a really nice standard that I just discovered over the last couple of weeks, right? Which is called MQTT. It was originally from IBM. So it's message queue telemetry transport, which should tell you something about it. And it is designed to be low footprint, small footprint. It's a basic pub subsystem. It's topic based, so you've got this nested set of things, which is arbitrary. You can have it any way you want. And in line with the kind of style of programming that Liam was talking about, you can actually choose the quality of service. So you can send stuff out, which is quick, and it may or may not get there. You can send it out so it will get there, but it might get there more than once. And you can get a completely locked version that actually will get there just once. So that's kind of nice. And it runs over TCP. You can put SSL on it. And in fact, it's so lightweight that the broker, the server side of it, can actually run in a router. And in fact, if you look over there, the little black box over there is a router that has actually been flashed with a router-based version of Linux, which is called OpenWRT, and that's also running an MQTT broker in there. So just on the router, you can have your own pub subsystem in your very own house, and it works cool. That's fab as far as I'm concerned. So we've now at least got transport for the Internet of Things stuff. They can talk to it. And this is, as I say, really moving fast. Last Sunday, the guys who are doing the Lua actually released an MQTT module for the ESP. So that little thing, well, before I blew it up, can actually talk directly to a TCP/IP enterprise class pub subsystem, which I find pretty awesome, and it really gives us a lot of things to play with. So bit of code which kind of looks familiar. Every 10,000 microseconds, go and read something off the A to D converter, which happens to be a thermometer. This is just exception catching. It's not a very pretty way of catching exceptions, but that's the way Lua does it. And that says publish the temperature out onto a topic called temperature. So, and that's what one of those items is doing right over there. So there's actually 2 ESP chips there sitting there on the Wi-Fi that I've set up, publishing to that. So if I'm very brave now, we might actually see that. Yeah, 828 times, temperature in here is 19 degrees C. So that works fine. It also works the other way around, again, being terribly brave. So if I click on this button, that blue light should go out, and it comes back on again. Well, actually, you can connect to the thing yourself and look at it. It's called Meteor London. It's an open network, and the address is 192.11.2, port 3000. Thank you. So we've got high-level ability to do this, and we can do that. So now, how do we get into Meteor? I would have used streams, except this nice bloke actually told me they don't work in 1.0. So I did this, I kind of extracted the meat of the streams code into this little bit here. As many of you, most of you will know, who've done Meteor, right at the bottom, you got this boilerplate bit of code you write for any collection which says publish, and then it's got a publish function, and your publish function is usually some selector, some find, you know, mybooks.find, whatever, right? But it's 2 pieces, it's 2 separate pieces. It's important to remember that, right? There is the publish up to the client, right? And then there's the publish function, which is the thing you're publishing. It doesn't have to be a collection, right? In this case, right, as you can see, I don't have that. What I do have is something from the npm MQTT module, which says that when I get a message in, build up a bit of JSON, which is going to be the body of my message. And then the self.added is telling the DDP code that I've added something, I've added a document. It's a virtual document, but I've added a document to this collection that is going upstairs, right? And this little bit here, that's the message, and this is the ID. At the moment, I just use a date stamp. So from the point of view of the Meteor client, all I'm seeing is a continuous stream of new documents that aren't going through Mongo, right? But are coming sequentially up at me, just as fast as they can. Streams is a good way of doing it, and now we're going to have this argument about whether it's actually fit for purpose at this point. On the client side, you can treat this pretty much like it was a regular Mongo collection, which is really neat. So we're not subverting Mongo in Meteor in any great way, but we are managing to get nice fast events out of these tiny objects cleanly, right? That right down on the template side is treated just as normal. So that little display you saw in very small letters, right, showing you the temperature is just that, and nothing special about that. I mean, at some point I'd like to ask Liam about how on earth we're going to integrate WebRTC with the Meteor world, and that's another good question for another day, possibly. So that's how you string the stuff together, very briefly. And the nice thing is it's all standards-based, it all works, and it'll scale out. I can have, in this case, I've got 2 things, right? I've got the thing with the lens that we switch on and off, and I've got my thermometer thing, right? But they're both on the same screen. They're integrated together. In fact, the Meteor app doesn't really know that it's two separate things. And it certainly doesn't know about IP addresses or anything else. All it knows is topics going backwards and forwards, right? So I've got a nice way of decoupling my big nest of IoT things out there, right, from actually the logic, the semantics of what I'm trying to plug together, right? And I can manage those separately. Also, I don't know how many of you were connected up to this. You guys are getting the pub/sub messages spread out to you, so I've got a many-to-many, and I can play with that as much as I want. Obviously, Meteor gives us its normal, great cross-platform, full stack, all the other nice things we get out of Meteor. We still get those, but we've now plugged cleanly the pub/sub nature of a standards-based IoT bus in there, and we haven't changed the thing around. And so it kind of looks like that, right? I think the neat thing about this is that it's unlike some sort of trick with the REST API and looking at this. We've got something that actually can be scaled out to hundreds and hundreds of objects. Normal kinds of clients we can scale with Meteor, whatever the scaling issues with Meteor are. But the whole thing fits together and actually is inherently okay for doing this kind of stuff. We don't actually have to use MQTT-based servers. Things like RabbitMQ will actually work in multiple dialects, including MQTT, so you can actually plug in full, big-arsed industrial strength message servers on this. For me, this is very basic, and I just wanted to show you these bits of scraps of code and the way this fits together, because if I made you a big, complicated demo, apart from the fact that I haven't had time, it wouldn't be quite as easy to see the very simple bits of how you fit this together. One thing I'm going to do, I think, is probably make a formal MQTT package for Meteor, right? I have to say, if you go and look MQTT Meteor, you will find somebody's already done this once, but they did it by persisting through Mongo, right? Which works as far as it goes. But what I was interested in is having that high reactivity, and pretty much, the goal is to be able to fly a drone through this, right? I think also, and it's sort of touching on the first speaker, sorry, name I can't remember, is that I think we could do with more conventions in Meteor. And in this case, I think if we sort of agreed on some conventions for how we name topics, it means we can write standard bits of code. For example, suppose I have topics that start with persist. Then I'd make the package actually say, well, in fact, those actually get persisted. The temperature might be a time series I want to see, in which case I write subsequent records into Mongo. Or it might be a continuous variable that I do want to maintain the state of, right? And those want to be persisted. So you do want to mix and match. But the doorbell, I don't particularly want anything other than it want to go off when it goes off, right? There's one other thing, which probably I'm going to reserve for another talk if they'll have me, you guys, is the interesting thing out of this is because the code for doing this kind of stuff, in comes a message, you render it in some mechanism in a standardized way on the template, right? Or somebody pushes the button and you send a standardized message down the other way to the topic and whatever's on the end of that. That does lend itself to actually making a universal application. What do I mean by that? Fundamentally, the code you're going to write for doing this stuff is going to be so similar that you could do it over and over and again, just having different templates. And there's a real neat trick that I discovered a few weeks ago, just before Christmas, which is that templates don't have to be static, right? You don't actually just have to always render a template out of a file. Some of you may have seen in 0.9 and onwards that there's a template dynamic, right? But that's still from a file. What you can do is actually store your templates in Mongo, compile them on the fly, and then insert them into the list of templates. And the impact of that is that you can make a template editor, make different screens, slam them in, and suddenly you've got a way of talking to your Internet of Things without actually even programming any Mongo, just writing straight HTML templates, right? Do you get that? Yeah. So that's a very interesting potential for the next thing, because in fact you can then package that up as a native app, put it in the App Store. When you've got a matching website that gives you your editor on big screen, but in your hand, you can actually make customized UIs for Internet of Things. And the great thing about this is that that means that at the end of the day, you're programming in one place, which is just on your little moat here, right? And you can just then edit any UI you want pretty straightforwardly. And that's something I'm trying to work towards. If anybody wants to help, I'd be very grateful. That's it.